Hey, all, today we are going to continue talking about describing distributions. And in this case, we are going to talk about more than one distribution and how we can apply those same principles of talking about the shape, unusual characteristics, center, and spread to compare two or more quantitative distributions. So here we have two histograms, and those histograms represent the number of public parks in the number of campsites in each public park in the states of Wisconsin and Vermont. And every time I do this problem, I get a little confused because of where the names are. So Vermont is down here and Wisconsin is here. And we also have the one variable statistics, things that we've calculated together, our counts, n, our mean. In this case, we probably have the number of campsites for every public park in each state. So they would be mu. We have the medians, the middle number, standard deviations, minimum, maximum, Q1 and Q3, which we'll talk about together. And so what we want to do is compare these distributions. And so we want to hit the four main points. We want to talk about the shape. We want to talk about the unusual characteristics, the center, and the spread. And so when I look at both of these, the one thing I would want to say, and we always want to use comparing words, like one has more, one has less, greater than, less than. We always want to be comparing these. We want to do it in context. Of course, we'll do it in complete sentences, but for the sake of time here in our lesson, I will just kind of document and talk about what we should say. So if we look at both of these distributions, I like to draw a little curve over them just to get, a general idea of what they look like if I can't see it by looking at the bars. I would say that both of these distributions are skewed to the right. So we would say something about both distributions for Wisconsin and Vermont and the number of campsites per public at each public park are both skewed to the right. We want to make sure that we identify what it is we're talking about in this problem. We want to say that they are both skewed right, and of course, we want to say choose the right shape, skewed right. Skewedness follows the tail. And when we talk about unusual characteristics, we want to talk about maybe gaffes or outliers. Potential outliers are probably the most important thing to talk about here. And I would say that in Wisconsin, we have a potential outlier here, perhaps there. And maybe in Vermont, we have a potential outlier here. So we can say that in both states, there are public parks that have a number of campgrounds that are potential outliers. So they both have potential outliers. And we can talk together about how to calculate if something is an outlier. And then we might want to say like where they are. So in Wisconsin, we would want to say that the potential outliers are at around 400 campsites and maybe like 480 campsites. We're estimating here. And in Vermont, we're at about 280 campsites. We'd want to give this is quantitative data. We can measure it in number of campsites. So we want to use the units when we talk about it. Since they're both skewed data sets, we are going to want to talk about the median as a measure of center. As you can see in both of these outputs, the median value is different. It's less than the mean value. And that's because these potential outliers, these data points way to the right that are much bigger than the rest, are going to drag the mean towards them. And so in this case, when we have this skewed right data sets, the mean is going to be higher than it normally would be if it were symmetric. If we had a skewed left data set, it would be lower than the median. So we want to talk about the medians. We should identify what the medians are when we're saying them. So the median for Wisconsin is 60 campsites, and the median for Vermont is 43.5 campsites. And we might want to say that the median value in Wisconsin is larger than Vermont. So I'm going to say Wisconsin is greater than Vermont. And then if we were talking about spread, we don't want to talk about standard deviation here because we have skewed data. We would want to talk about either range, so we can do the minimum minus the maximum. So we can say that the number of campsites in Wisconsin has a larger range. They range from 0 to 472 campsites, whereas in Vermont, the data is less spread out. The range is from 0 to 275 campsites. We could also talk about the IQR, the middle 50%, and we calculate that by doing Q3 minus Q1. We can talk more about that together. But if you want to just talk about the regular range, that would be fine. So we can say that in Wisconsin, the data is more spread out, which we can see by looking at the histograms or by looking at the data. And we would want to say the range is 472 compared to 275. Okay, we would write this up in complete sentences, always making sure we stay within the context of the problem. Campsites at public parks in Wisconsin and Vermont. And so we can do that whether or not we have data that we need to put in and create a data display, or if we have different types of quantitative data displays. And so here we have home runs hit by teams in the National League, in Major League Baseball, and in the American League. And these are back-to-back stem and leaf plots. But we can get the shape of them. This data maybe isn't super exciting because there aren't very many areas where we have a lot of data points. But again, we would want to compare them using our 4, and I really should say 5 key components, because we always want to hit context. So maybe we can add a last C. We always want to remain in context. So when we're just comparing these two distributions, let's always make sure that we're talking about home runs in the National League, in the American League. Even if you don't know anything about baseball, much like me, I don't know a lot about baseball. We can still use the language in the question when we're describing them. So I would say that both of these shapes are relatively symmetric, approximately symmetric. So we can say that both distributions of home runs in the National and American League are approximately symmetric. There doesn't seem to be any potential outliers. You might have some concern with that one right there, but it's not too far above the rest. So no outliers in each data set. We could look at the center of this data, and I would say that the center of the National League data, and we're going to want to talk about mean here because we have approximately symmetric data. The mean is around, I would say, somewhere in here. So maybe 140 home runs. So in the National League, 140. And the mean in the American League is going to be a little bit higher, maybe somewhere in here, 180. So we can say the mean in the American League is higher. We can talk about the standard deviation. There's ways to put this into the calculator. We won't do that right now. but we would want to talk about the standard deviation. But I think we can say safely that, let's see, the American League data is slightly more spread out. And then, of course, that last C, which I wrote up top there, is context. So make sure that when you're writing this up, you're always referring to the context of the problem. We're talking about home runs, we're talking about the National League, and we're talking about the American League. So I have another stem and leaf plot. These data sets I think are a little bit more interesting. They give us a better shape. Before you answer the questions, I'll sort of do my little sketch over the shapes for you. If you have questions, do ask. Make sure you stick around to the end and answer the questions associated with this problem here. If you cannot see it, it's in the textbook for 1.4, not in the practice, but in the actual text. So if you need help finding that too, ask. But stick around, answer the questions, and good luck.